This military car is made possible by high-speed production of thousands of small parts made in machine shops to exact dimensions by skilled craftsmen. Thousands of parts, like tapered steel shafts, are assembled on fast production lines with full confidence that they will fit and function perfectly. This is possible only because of modern machine methods. The tapered shaft is an important part often produced on the engine lathe. A taper is a shape that increases evenly in size from the small to the large end. This drawing sets up the problem of turning a tapered shaft to the exact dimensions shown with the correct taper. We start the job with a drawing of the finished part and a partially finished stock. The operator must plan his work. Notice he has already machined the straight surfaces and faced the ends. On this job, for the first step, the steep taper will be cut to accurate shape and size. Then the long taper will be cut. In other words, there are two tapers to be turned to precise dimensions, the steep taper and the long sloping taper. It makes little difference which taper is cut first. On this job, the steep taper will be turned first. The compound rest is always used for the cutting of steep tapers on the engine lathe. The compound rest can be set at any angle. In preparation for the job, the lathe is checked to make sure the ways are clear of chips and dirt, and that the centers are clean. And now the stock is made ready for the lathe. The dog is placed over the small end of the stock and tightened in place so the work will turn with the head center. Then the center hole, which goes on the tail center, is lubricated. Now, to determine the setting of the compound for the proper angle, the drawing is checked. This diagram shows how the compound rest is set to cut a steep taper. Point the compound in the same direction as the taper surface of the piece shown on the drawing. When the dimension of the taper angle is given like this, using the mark stamped on the base of the compound, count off the number of degrees shown on the drawing like this: 5, 10, 15, 20. When the dimension is given like this, point the compound toward the tailstock, setting the compound parallel with the center line of the machine, putting the 90-degree angle mark over the index mark. Count the marks: 5, 10, 15, 20. To set this angle, use the graduations which are shown in degrees on the base of the compound. The steep cut is to be at an angle of 20 degrees, so the compound is set at 20 degrees. The compound must be locked in place. The surface is irregular, and so a truing up tool is used for the first cut. It is set on dead center and at right angles to the surface. This set is common to all taper cutting. The carriage feed is disengaged, the carriage is locked in position, and the lathe is started. This truing up cut permits accurate measurements with a bevel protractor. To do this, the head is placed against a reference surface, a surface that is finished and is true. The protractor blade is adjusted until it lies flat on the cut. The angle is shown by the graduations on the protractor head. Here the angle checks with the specifications, 20 degrees. Next, the diameter of the work must be checked with the drawing. Never rely on memory. Check the drawing for all measurements. The protractor measures the angle. The micrometer measures the size. The piece measures 120 thousandths of an inch oversized. On this lathe, a tool set of 110 thousandths removes 110 thousandths of metal and leaves 10 thousandths for finishing later. A roughing tool is used. After the roughing cut, another measurement is taken with the micrometer on the large diameter. We now have 10 thousandths for finishing. The operator has changed to a finishing tool, which he sets on dead center with the nose parallel to the surface. In order to remove 10 thousandths, the tool must be set for a cut of 5 thousandths of an inch. In this slow motion view, we can see, ahead of the tool, the rough surface left by the roughing tool. Behind it is the smooth surface left by the finishing tool. A check with the drawing and the cutting of a steep taper is completed. Tapers of 15 degrees or less are cut with a taper attachment. Notice this taper is given in terms of inch of taper per foot rather than in degrees. Here is the principle of a taper attachment. A shoe moves along on the slide. It is connected through another arm to the cutting tool. This makes the tool move along at a slant. Now watch what happens to a piece of stock. The tool now moves along the work at a slant, and so it makes a tapered cut. To use this attachment, first disconnect the cross-feed screw. This frees the cross-feed slide so that it will follow the movement of the traveling shoe. Second, the bracket is set so that the shoe comes in the approximate center of the slide. Third, the bolt which holds the connecting bar to the shoe is tightened, and now the cross-feed slide will follow the shoe. The slide of a taper attachment may be swung in either direction. Setting the slide according to these graduations determines the taper angle. Now the slide is set to a 1 1/2 inch taper per foot as specified in the drawing. The slide is set parallel to the taper which will be cut on the tool side of the work. And with the setting adjusted, the bar is locked in position by tightening the bolts. Tapers such as this are generally cut at the tailstock end. The tool is fed to the work with the compound, set at right angles to the work. Now the shoe will push the tool along its proper path, guided by the setting of the slide. All adjustments are made. The power is turned on. Then the carriage feed is engaged. Only a light cut is taken until the correct taper has been established. On this type of turning, the accuracy of the taper is checked with a taper ring gauge. The gauge is slipped over the taper. Here the gauge fits loosely at the large end. This looseness means that the angle of taper is too small. Wear and lost motion make the slide marks only approximate. To correct the taper, the slide must be reset for slightly more than 1 1/2 inches per foot. In replacing the work between centers, the tail center hole is lubricated. This should be done at every possible opportunity. As always, when placing the work in the lathe, the tailstock spindle should be checked to make sure there is no binding. To find the setting of the tool for the next cut, the tool is run against the work at the small end. The carriage is then racked over. The tool is set for a skimming cut of 10 thousandths at the small end. The depth of the cut is a matter of judgment based on knowledge that this is not too deep. When this cut is completed, the lathe is stopped, the work taken out, and again checked with the taper ring gauge. The taper is now correct. The work can be finished to the right diameters. The actual diameter of the small end of the taper is measured with a micrometer. The drawing gives the required diameter. The piece is still 10 thousandths over size. The compound is set accordingly. The cut will continue for only a very short distance. The taper extends clear to the shoulder, and the micrometer measures 1/4 inch from the shoulder. So the reading given by the micrometer will be slightly over 31 thousandths more than the real diameter of the shoulder. Note that the micrometer spindle for this reading is held flush with the shoulder. Here is the completed job with the two finished tapers, one turned by using the compound rest, the other by using the taper attachment. The piece is not yet ready for use. The bevel gear teeth must be cut and the end threaded. Later, when this is done, the piece will be ready for assembly on the production line. Here, the skill of the operator and the quality of the workmanship meet their acid test.